Alright guys, today's goal, the learner will understand how to use matrix algebra. So we're going to be talking about matrices, matrix addition and subtraction and multiplication, identity and inverse matrices, determinant of a square matrix, and applications. Matrix algebra provides a powerful technique to manipulate large data sets to solve related problems that are modeled by the matrices. Okay? So, what this is saying says let m and n be positive integers. M is the number of rows, n is the number of columns, and it's read m by n is a rectangular array of m rows and n columns of real numbers. So let's take a look. They just want to know what is the order of the following matrix. What that means is how many rows? 2 by 3 columns. Okay, so that's the order for that. You can also use shorthand notation, meaning I is the number of rows, J is the number of columns there. Okay. That's not that commonly used, but it can be used. So, let A be Aij, let B be Bij, be matrices of orders m by n. The sum A plus B. You add the Aij plus the Bj, so watch what happens here. Sum and difference. So, it says add. So watch what I do. Okay, so how did I get these pairings? 1 plus 2, 2 plus 3, 3 plus 4, 4 plus 5, 5 plus 6, 6 plus 7. So now you add them together. You get 3, 5, 7, 9, 11, 13. So there's the matrix. In order to add matrices, they have to be the same size, same order. Okay? Same thing for subtraction. Same size, same order. You do it the same way. Now, to multiply a matrix, distribute it to all of it. So you get 3, 6, 9, 12, 15, 18. That's what that 3 times the matrix means. Okay? Now, the matrix m by m, matrix 0, consisting entirely of zeros, is the zero matrix. Okay? So it says let A be matrix Aij be any m by n matrix. And let m by n matrix B be A by J, consisting of the additive inverse of the entries of A, is the additive inverse of A, because A plus B equals 0. So if you ever add two matrices together and they all equal zeros, then that was an additive inverse. That's just a property. So let's look at some more math with these. It says find product AB if possible. So 1, make sure you have your graphing calculators out because I showed you how to enter matrices into your calculators. Okay? So make sure you have that out. Now 2, to see if it's possible, the reason it says if possible, write down the size. This is 2 by 3, and this one is 3 by 2. That's what you're multiplying, right? What you have to check is, do these two match? Yes, they do. And what you're going to end with then is a 2 by 2. Okay? Now I'll show you the long way, but we'll show you in a calculator how to do it as well. So, what you need to do. So what we have to do is you do first row times the sum of the first column. So watch. You get 1 times 1 plus 2 times 2 plus 3 times 0. Then you do the first row times the second column. So you get 1 times 0 plus 2 times 1 plus 3 times negative 1. Then we go and we do second row, first column. So you get 0 times 1 plus 1 times 2 plus negative 1 times 0. Second row, second column. 0 times 0 plus 1 times 1 plus negative 1 times negative 1 equals. Now I just add them up. So it's 1 plus 4 plus 0, 5. 0 plus 2 plus negative 3, negative 1. 0 plus 2 plus 0, 2. 0 plus 1 plus plus 1, 2. So there is the product, the matrix 5, negative 1, 2, 2. See how the 2 in the middle match, and you end up with the 2 by 2 outside. Okay? All right, this property here, it says, let A equal Aij be n by n matrix. If there is a matrix B such that AB equal matrix A times matrix B equals B times matrix A, it equals, then they are known as the inverse. Then B is the inverse of A. We write B as A to the negative 1, meaning inverse. Okay? Another, it says the n by n matrix, I sub n, whose 1s are on the main diagonal and 0s elsewhere, is the identity matrix. So see how it starts with 1, then 0s, then it goes 0, 1, 0s, then it goes 0, 0, 1. See how the 1s are on that main diagonal? That's called the identity matrix, meaning when you multiply, and it's always same number of rows, same number of columns. That's what this n by n means. They match each other. Okay? Okay, so it says, if AD minus BC does not equal 0, so A times D minus B times C, if that does not equal 0, then the inverse of that matrix is equal to 1 divided by AD minus BC times, and then it's D negative B negative C A. So the A and the D switch, and the B and the C become negative, and the number AD minus BC is called the determinant. So let's see how we can apply that to get the matrices, to get the inverse. So it says, find the inverse of the matrix if possible. So the first thing you got to do, 5 minus 6, that equals negative 1, so it doesn't equal 0, so we're good. So then, remember, you do 1 over negative 1 times 5, negative 3, negative 2, negative 1. We're just following the switch. So that's negative 1 times that. So that would equal negative 5, 3, 2, 1. So there's the inverse of the 2 by 2. We'll show you how to do larger than 2 by 2 ones in the calculators. But for 2 by 2, you need to be able to do it without the calculator. Okay, so let's look at some more properties. Alright, so it says, let A, B, and C matrices whose orders are such that the following sums, differences, and products are defined. The community property means A plus B equals B plus A. Multiplication does not hold in general. Associative property. A plus B plus C is the same thing as A plus the quantity B plus C. Multiplication, if you do A times B times C, that means that's the same thing as A times BC. Identity property. A plus 0 equals A. For multiplication, A times The identity equals the identity times A, which still equals A. Inverse property. A plus negative A equals 0. Multiplication. A times the inverse, which is the inverse times A, equals the identity. And the absolute value cannot be 0. Distributive property. Multiplication over addition. It says A times the quantity B plus C equals AB plus AC. And the quantity A plus B times C equals AC plus BC. Now over subtraction, it's A times the quantity B minus C equals AB minus AC. The quantity A minus B times C equals AC minus BC. These are all properties we're going to have to use. Okay, see you guys tomorrow.